In our first video about Surds, we will start to look at the process of simplifying Surds, where we would take a Surd in a more complex form. For example, at National 5 you might have an answer to a question that comes out as, for example, the square root of 12, and you would be asked to write that in its simplest form. So we need to go through the process of how we do that. To begin with, we have two rules or facts that we use when simplifying Surds. What we're going to focus on in this video is we're going to focus in on this type of Surd. And that fact says that the square root of any number, a times b, is exactly the same as the square root of a times the square root of b. And we use that to simplify Surds in these kind of two-step process. We look first of all for any pairs of factors that give you the number a times b. And what we're looking for specifically is we are looking for the largest square number factor that we can find. The reason why we want to use square number factors is because if I know the root of a square number, I can immediately say what that square root is. We see a little table here that gives us the square numbers from 2 squared all the way up to 10 squared. It would be really important at National 5 that you know all of these, if not off by heart, that you would be able to find them very quickly. So to begin with, I'm going to look at this example of the square root of 8, and I'm asked to simplify that. So I am going to look for pairs of factors that give me a times b, then a times b is 8. So I'm looking for a number a and a number b that multiply together to give me 8. It's usually helpful to write this off to one side. So I want to look for the factor pairs that give 8. And I'm going to go through these quite methodically. I'm going to start with 1 times a. That will always be a factor. I'm now going to just go through my times tables and think about whether 8 is going to be in that table. So I then want to consider is 8 in the 2 times table. Well, it's an even number, so it definitely is. So that's going to be 2 times 4 to give me 8. I'm going to then consider the 3 times table. Well, 8's not in the 3 times table. I then come to the 4 times table, and I've already used that, so I'm confident that I've got all the factors of 8 in place. Now what I want to do is I want to look through these square numbers, and I want to see which ones appear in the factors of 8. And the only one that appears there is 4. So we're going to use that to simplify the square root of 8. Okay, so the square root of 8 is the same as the square root of 2 times by the square root of 4. But I'm going to write that in a slightly different order. I'm going to write the square root of 4 first. And the reason why I write the square root of 4 first is just because it looks a little bit neater when I go ahead and simplify. Okay, so I'm writing my square first. I'm going to put a wee note to say that. So we want to write the square factor first. That'll just help us later. So now, the square root of 4, well, if I know that 2 squared is 4, so that means the square root of 4 must be 2. So that means that is 2 times the square root of 2 cannot be simplified any further. So the square root of 8 simplifies down to 2 root 2. Okay, let's look at a few more of these. So I'm now asked to simplify the square root of 12. So let's go through my factor pairs of 12. So 12 factorises down to 1 times 12. It is in the 2 times table because it's an even number, so it factorises to 2 times 6, and 12 is in the 3 times table, and it factorises to 3 times 4. Now I've already got 3 and 4 here, so again I'm confident that I've got all factor pairs of 12 that are going to be of any use to me. Looking for square numbers, I have only, again, square 4. So that means that the square root of 12 is equal to either the square root of 3 times the square root of 4, or, in the way it's easier for us to write it, the square root of 4 times the square root of 3. Now I'm going to just pause for a little second. It's also equal to the square root of 2 times the square root of 6. But that's not any use to us. We can't simplify either of those anymore. And we'll come back to that a little bit later on in another video. So the square root of 4, as we said just a wee moment ago, is equal to 2. So that means that the square root of 12 is equal to 2 times the square root of 3. Or we would say 2 root 3. Okay, let's now look at the square root of 48. Now this is going to illustrate for us that there are often numbers that have more than one square factor. So I look at the square root of 48 and I want to start going through my times tables that give me 48 as a possible answer. So 48 has quite a lot of factors. It's 1 times 48 to begin with. It's an even number, so it's also 2 times 24. Now I want to go through this methodically. I want to check if 48 is in the 3 times table. Now we normally only learn up to 3 times 12, that's 36. But 48 could be in the 3 times table, and remember a quick way to check that is to take the digits 4 and 8, add them up to give me 12, and if 12 is in the 3 times table then 48 will be. So 48 is in the 3 times table. It's 3 times 16. And there's absolutely no harm in just writing out a little calculation if you don't know that off the top of your head to work that out. Okay, let's continue on. Now, is 48 going to be in the 4 times table? It is, but just to show you a way we can do this, 2 and 24, well if I double 2 to give me 4 I have to half 24 to give me 12, so it's 4 times 12. And last of all, is it in the 5 times table? No, it's definitely not. Is it potentially in the 6 times table? Well I've got 3 times 16, if I double 3 to give me 6, I half 16 to give me 6 times 8. Now I just want to go through that list and I want to identify any square number factors. So I have 4 here, but I also have 16. And it's important, as we said up here, to use the largest square number factor. So I'm not going to use 4, I'm going to use 16. So the square root of 48 is equal to the square root of 16 times the square root of 3. I do that because I can then see the square root of 16 is equal to 4 times the square root of 3, and that gives me my answer much more quickly. So again, perhaps a little note we want to put here is that we want to take out the largest square factor. That's important. Okay, the largest square factor. Okay, let's look at one final example in this video. So we have now the square root of 75. So 75 is just going to factor down initially to 1 times 75. Is it going to be in the 2 times table? It's an odd number, so it can't be in the 2 times table. Could it potentially be in the 3 times table? Well, 7 and 5 to give me 12, and 12 is in the 3 times table. So it's 3 times, and again, if you're not sure, a little calculation and check it. So 3 into 7 is going to go twice with the remainder of 1, and 3 into 15 will go 5 times. So it's 3 times 25. 75, that would be in the 5 times table. And just for quickness, it's 5 times 50. So as I look through these numbers, all I see jumping out at me as a square number is 25. So the square root of 75 simplifies down to root 25 multiplied by root 3. I can simplify root 25 down to 5, so the square root of 75 is equal to 5 root 3, and that's my final answer. So we looked at a few examples of that in this video. In the next one, we will look at examples which look like this up here, where we are dealing with fractions or division of surds.